Hello, am I audible and is my screen visible? Please someone let me know.
Yes, to both.
Yes, sir, you are audible and
Okay,
your screen is visible.
okay, thank you. Good evening everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my third live session. In this live session I will discuss some practice problems on week 3 topics, and in week 3 logistic regression and linear discriminant analysis, these two topics were covered. So we will discuss some practice problems on these two topics, and if you have any questions or queries regarding these topics, you can ask me. So we will start discussing some problems on these topics, and after that if you have any questions or queries, please feel free to ask me. This is the first question. This is on logistic regression. Which of the following is false about logistic regression based classifier? So there are four options. You have to find out the false option, and there might be multiple correct options here. First option is the logistic function is a non-linear. The logistic function is non-linear in the weights. Second option is logistic function is linear in the weights. Third option is the decision boundary is non-linear in the weights, and the last option is the decision boundary is linear in the weights. So which of these following is or are false about logistic regression based classifiers? You can write your answers in the chat. I have not received any answer in the chat yet. So is this question understandable properly? Okay, I've got one answer in the chat. Orijit Saha is saying A and C. Anyone else? You have to find out the false options here regarding logistic regression.
Sir, could you explain much about logistic regression?
So logistic regression is a linear classifier, and so okay, I will So the correct answers are B and C. So I will explain all these things. So logistic regression, this is a linear classifier. So it tries to find out a linear decision boundary, straight line decision boundary. So if fx is the decision boundary, it is of the form w transpose x plus b equals 0. So this is the decision boundary line. So this is linear in nature, as you can see from this equation. W transpose x plus b, x is the input features, and w is the weights, and b is the bias. This is also part of the weights basically. So this is the decision boundary. So this decision boundary is certainly linear in w, because this w transpose x plus beta is basically w into x plus beta. So decision boundary equation is completely linear in the weight values, which is represented by w here. So decision boundary, okay, no, B and C are correct options here. So the decision boundary is linear in the weights. So that's why the option C is false. That would be one of the correct answers. That decision boundary is non-linear. Decision boundary is actually linear in the weights for logistic regression. And second thing is about logistic function, whether it is linear or non-linear in the weights. So the logistic function or the sigmoid function of z is written by 1 divided by 1 plus e to the power minus z and in place of z we write this w transpose x 1 plus e to the power minus w minus w transpose x. So this is the weight value w, and this is the logistic function 1 divided by 1 plus e to the power minus w transpose x. So this is certainly not a linear function on w. This is an exponential function, and then we are taking the inverse of it. So this function sigmoid, also known as logistic function, is certainly not linear in the weights. It is non-linear in the weights. So the wrong option would be linear in the weights. So that's why B and C are the two correct answers here. Is it understandable? Is there any other doubt in this question? So basically you have to write down the decision boundary equation based on the weights and the input x, and you also have to write down the logistic function based on the w and x, and then you have to see whether it is linear or non-linear on the weights or not. Moving on to question 2. Consider the case where two classes follow Gaussian distribution which is centered at 3, 9 and minus 3, 3. So a 2D plane is considered here. So two Gaussian distributions, the first one is centered at 3, 9 and second one is centered at minus 3, 3 and have identity covariance matrix. Which of the following is the separating decision boundary using LDA, assuming the priors to be equal? So if we use linear discriminant analysis on this distribution of data points, then what will be the separating decision boundary? So there are 6 options here. Y minus x equals 3, a straight line, x plus y equals 3, another straight line, and x plus y equals 6. Option D is both B and C. Option E is none of the above. Option F is cannot be found using the given information.
Can you explain what is prior probability?
So have you gone through the video lectures for LDA?
Yes, I have.
So in LDA we try to find out probability of g equals k for a input x, for an input x, which is equal to f x k pi k divided by sum over f l x pi l. So do you remember this one from the video lectures?
Yes, yeah, I remember.
Yeah, so this pi k pi l, so these are the prior probabilities. So basically how many of the of all the data points belong to kth class or the lth class. So these are the priors uh, for a given class, and in this question the priors are all equal for all the classes. So there are two classes, so prior values are half and half for the two classes.
So prior is basically the product of that px raised to y into 1 minus px raised to y minus 1 minus y, is it?
No, prior is this pi only, this pi k. This is the prior for the kth class. Pi k is nothing but nk divided by capital N. Nk is number of data points for that belong to kth class, and n is the total number of points. So what fraction of the points belong to kth class? That is the prior for that class.
Thank you.
So in this question you have to find out the decision boundary for the two classes that follow Gaussian distribution. One is centered at 3,9 and the other class is centered at minus 3,3, and both have identity covariance matrices. I have not received any answer in the chat. So this question might seem a little difficult, but actually not that difficult. There might be many different information given in this question, but it's okay. I've got one answer.
The
Shruti,
answer is both B and C.
both B and C. Okay, that means you're saying D, option D. Okay, and Shruti is saying option C. So I've got two answers. So for this question, it would be easier if we plot these two centers. So the first center is 3 comma 9, so it will be somewhere here, and the second one is minus 3 comma 3, so it will be somewhere here. So these are the centers of the two Gaussian distributions representing two different classes, and the covariance matrices are identity covariance matrices for both the distributions. So in that case, if we apply linear discriminant analysis, the separating hyperplane would simply be, first we have to join these two centers and create this line segment, and it would go through the midpoint of the separating decision boundary will be perpendicular to this line segment joining the two centers and going through the midpoint of this line segment. So this is the midpoint, and it will be perpendicular to the line segment joining the two centers. So this is the decision boundary, decision line or decision boundary. So the 2 points are given, 3 comma 9 and minus 3 comma 3. So from these two coordinate values we can find out the center, find out the midpoint of this line segment joining these two centers. It would simply be, it would be 0 comma 3, I think.
0,6.
Oh yeah, 0 comma 6, it will be 0 comma 6, this point is 0 comma 6, and then we have to find out the slope of this straight line. So slope of this line segment joining these 2 points, slope of this line segment joining the two centers, if we denote it as m, so it would be 9 minus 3 divided by 3 minus minus 3, so it would be 6 by 6, which is 1. So slope of the line segment joining these two centers is 1. So slope of the line perpendicular to that line segment would be minus 1. So if we denote it as m1, so m1 is the slope of the decision boundary which is perpendicular to the line segment joining these two centers, so it will be minus 1. So we have got this slope, and we have got 1 point through which the decision boundary goes through. Using these two informations we can find out. So if the straight line is y equals mx plus c, equation of the straight line is this, and m is minus 1, we have find out, we have computed it from here. So it will be minus x plus c, y equals minus x plus c, and we already know 1 point 0 comma 6 which lies on this straight line. So value of c is y is 0.
Why minus 1 is 1, no?
1 is the slope of the line segment joining these two, this for this one, the straight line that joins these two centers, that is 1. So this, for the straight line which goes perpendicular to that line, would be minus 1, isn't it? If two straight lines are perpendicular to each other, then the product of the slopes of the two straight lines should be minus 1, isn't it?
Yes, yes.
So if one is m1 is 1, then m2 will be minus 1. So the line perpendicular would have a slope value of minus 1 if the line segment has a slope value of 1. So from this we can find out the c is 6, so it will be y equals minus x plus 6, which is x plus y equals 6. So x plus y
Sir, how
equals,
did you find 0 and 6?
so that is the midpoint of this line segment. 2 points are given, 3 comma 9 minus 3 comma 3, so you just have to take the average of x coordinate and y coordinate, that will give you the midpoint of that line segment, and the decision boundary must go through that line.
In this case, option number B and C both are perpendicular to the line
Yeah.
joining the two means.
Yeah, both are perpendicular, but the option B, x plus y equals 3, doesn't go through the midpoint of the line segment.
Yeah, that's my next question. Like, what necessitates it to be the perpendicular bisector? Why can't it be just any line perpendicular to
No, I
the
mean
line?
any line cannot be a decision boundary, because then you can have a straight line like this. Sorry, uh, like a line like this, which is also you might call it a decision boundary, but it is not. It is very much tilted towards the minus 3 comma 3 center, isn't it? So it is tilted towards one set of points, but it should be exactly in the middle, because both the sets of points have identity covariance matrix.
So, is it because both the priors are same, or
Yes,
because
yes,
the
both the priors are same, and also the covariance matrix is also identity matrix for both the classes.
okay?
And also
So,
the priors are same, so that means equal number of points belong to first class and second class, so the decision boundary must go through the midpoint.
suppose the priors were not same in the
Yeah, in
one
that
had.
case the it would shift and you have to recalculate using the LDO one. This is much easier question, because if the priors are equal, you just have to find out the midpoint and the line perpendicular to the line segment that goes through that midpoint. But if the priors, you are given certain values of the priors, then you have to compute from the equation that I have shown you before, that fxk into pi k, from that you have to find out. That would be very difficult to compute in case of MCQ questions. That would not be very easy to solve. I mean, the straight line would not go through the midpoint, it would be shifted towards either first class or second class, but exact line, to find out the exact straight line, you have to do a lot of math for that. But in this case you don't have to do a lot of math, because number of points in first class and second class are same, and also the shape of the Gaussian distributions are same, because both have identity covariance matrices. Is it fine?
Yes.
Sir, I didn't understand about C equal to 6.
So this you understood, right? M1 equals minus 1, slope of the straight line is minus 1.
Yes, 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 yes.
So we consider the straight line to be a generic straight line, y equals mx plus c, and value of m is minus 1, we have already calculated. So this becomes minus x plus c, isn't it?
Yes, yes,
Then
yes.
we know that this is the point through which the straight line goes, 0 comma 6. So we can put this coordinates of the this point into the straight line. Value of x is 0, value of y is 6, isn't it?
Okay, okay, understood.
Yeah.
X value is 0 and Y value is 6.
Yes. So C is the correct answer, and explanation is given here in brief, that as the distribution is Gaussian and have identity covariance which are equal, the separating boundary will be linear and the decision boundary will be orthogonal to the line joining centers and will pass through the midpoint of the center. So using this logic we can calculate it. Now moving on to question 3. Logic transformation for probability of x equals 1 for given data is, so this is the data, s equals 0 1 1 0 1 0. So these are different x values, x equals 0, x equals 1, x equals 1, x equals 0. So from this data set x takes its value, and you have to find out the logic transformation for this probability of x equals 1. So the logit, many of you might not know. So the logit transformation of a certain probability p is given by p divided by 1 minus p. So this is the formula for logit transformation of a probability. So first you have to find out the probability of x equals 1, and then you have to apply this logit transformation.
4/3.
4/3. Okay, option B. Ankit Srivastav is saying B. Jigyasa Patel is saying B. Harapriya Kaur is saying B. Ritika Kesh is saying B. And Shravan is saying B. So all of you are saying option B. The correct option is option B. So this is the data set, and first you have to find out probability of x equals 1. So probability of x equals 1. So you just have to find out how many ones are there in this data set is. So there are 1, 2, 3, 4. 4 ones are there, and there are total 7 elements. So it will be 4/7, and then the logit of this probability would be 4/7 divided by 1 minus 4/7. So this is 4/7 divided by 3/7, which is 4/3. So yeah, option B is the correct answer. Question 4. Output of binary class logistic regression lies in this range: minus infinity to infinity, minus 1 to 1, 0 to 1, minus infinity to 0. Ritika is saying C, Raki is saying A, Ankit is saying C, Archa is saying C, Manjula is saying C, Najnin is saying C. So most of the answers in the chat are C. I have got one A also in the chat. Orijit Shah is saying C. The correct answer is option C, 0 to 1. So in case of logistic regression, this sigmoid function is used, 1 divided by 1 plus e to the power minus z. So this is the output that comes out from logistic regression, and if we plot this on z, so it would look something like this. So it ranges from 0 to 1 only. So the output of logistic regression would also lie between 0 to 1. Prijit Shah, do you want to say something? Your mic is unmuted. Oh.
No.
Okay. Question 5. Logistic regression is robust to outliers. Why? So you have to find out why logistic regression is robust to outliers. There are 4 options. Squashing of output values between 0, 1 dampens the effect of outliers. Linear models are robust to outliers. The parameters in logistic regression tend to take small values due to the nature of the problem setting, and hence outliers get translated to the same range as other samples. And option D is the given statement itself is false, that logistic regression is not robust to outliers. That is option D.
Is it option A?
Option A, which is squashing of output values between 0 and 1 dampens the effect of outliers. Okay, let's see what others are saying. Pradeep Kumar is saying A, Archa is saying A, Ritika is saying A. Raki is saying A. Harapriya Kaur is saying A. Anant Kumar is saying A. Okay, so correct answer is option A. So most of you have written the correct answer in the chat. So squashing of output values between 0 to 1 dampens the effect of outliers. This is the actual reason why logistic regression is robust to outliers. So whether the point is within its own class or it is an outlier or noise point, still the output value for that point would be within this range of 0 to 1. So it does not contribute that much error to the loss function. So if there are very few outliers, it would not hamper the performance of the training of that model. So this is why logistic regression is robust to outliers.
Hello, sir.
Yes.
Sir, having one doubt in week 3 quiz, can you go to question number 4
In the assignment.
in assignment? But I just want to know the explanation, not the answer. Just having the doubt with that log function. Actually, how to convert that log function into the with e? Can you tell me?
Question 4 in the assignment or in my problem set?
No, not in your problem. Assignment only. Quiz. Which question number 4 week 3?
Okay. No, I mean for the assignment deadline is not over, so
Sir, I'm not asking the answer. You just explain that question, na? Just explanation of the question I'm asking.
if you have any doubt in the question, you should
Yes, sir,
post in
I'm
the
having the
discussion
doubt.
forum.
Yes, sir. Sir, the doubt is how to convert this log function with the e.
I have not seen the
Sir, can you go through that quiz session?
mm, 1 minute.
Week 3 quiz. Question number 4.
Okay, this fourth question.
Yes, sir.
I mean, yeah, this is very easy. If you have gone through the basics of log, so what is the relation between log and exponential? So you should be able to do that.
Sir,
What is the inverse of log is e to the power, isn't it?
inverse of log?
So basic of log is what? E to the power. So log of e to the power x is x. So this is how log is related to exponential. So this is basic of log, isn't it? It just brings out the power in front. Power is x here, so the result is x. So you just have to have
Have to take the inverse of log, right? Na?
inverse of log is e to the power, isn't it?
Yes, that is.
So you have to apply that logic
Sir,
here.
inverse of log is inverse. That is the basics, na? Basic of log function. But here in this question, I'm asking for the explanation.
You have to do that transformation, then you'll be able to find out p of x. P of x is within this log. Now invert it and then find out p. I cannot say the whole answer. The assignment is not over yet.
Okay.
This question is not that difficult. I mean, I already told you that you have to take the inverse of log. I cannot tell more than that.
Okay. Thank you, sir.
Now question 6. We have two classes in our dataset with means 0 and 1 and variance 2 and 3. There are four options. LDA may be able to classify them perfectly. LDA will definitely be able to classify them perfectly. LDA will definitely not be able to classify them properly, and none of the above. So the two classes are given with means 0 and 1 and variance 2 and 3 respectively, and you have to find out whether LDA will be able to classify them properly or not, perfectly or not. That no data point should be misclassified, so it should be perfectly classified.
So LDA tries to increase the between class variance while minimizing the within class variance. That is
Yes. But in this case you won't need that logic. The fundamental thing that LDA tries to do is to find out linear decision boundary between the two sets of points. So whether LDA will be able to do that for this these two classes.
Sir, can you hear me?
Yes.
So I'm not sure. I'm just guessing. So we can see that variance for these two classes is 2 or 3. So maybe the Gaussian will overlap.
Okay, so then what is your answer out of these four options?
Based on what I said, I'm thinking they may be able to classify. I'm just guessing.
So you're saying that the two Gaussians will overlap. So but if the two Gaussians overlap, then how will a linear decision boundary be able to
Yeah, maybe
classify?
it will not be able to. Yeah, I think so.
Okay. Anyone else? Oh, I got two answer in the chat.
may be able.
Divyangs.
Option A may be able to.
Okay. Divyang's theory is saying option C. Rakhi says option C. C is will definitely not be able to classify them perfectly. So this for this question it would be easier if you plot the two Gaussians. So the question is on 1D data, but you can extend it for 2D data also. So if we extend it for 2D data, so let's say this is one Gaussian. The first Gaussian centered at 0, another Gaussian is will be centered at 1, but the variance of the first Gaussian is 2. So variance is 2, that means standard deviation is root 2, which is approximately 1.44. So the standard deviation is 1.44, but the second Gaussian is centered at 1. So that means center of the second Gaussian will be within this first Gaussian. So this is the point 1, which is the center of the second Gaussian. and its variance is 3, so standard deviation will be root 3, which is approximately 1.7. So it will be like this, the second Gaussian. So from the information given on mean and variance, we can see that the two Gaussians will overlap, because the standard deviation of the first Gaussian is more than the distance between the two means. So distance between the two means is 1, 0 and 1, so distance is 1, but the standard deviation of the first Gaussian itself is 1.44. So that means the second Gaussian, center of the second Gaussian lies within the first Gaussian. So the points will overlap, the two classes will overlap, so certainly you cannot find a linear decision boundary to separate these two perfectly. So LDA will find out a decision boundary, but that will not be able to perfectly classify. Perfectly classify means 100% accuracy it should give. But obviously if the points overlap, the two classes overlap, in that case you will not be able to find a perfect linear classifier. So option C will be the correct answer here, that will definitely not be able to classify them perfectly. So is there any doubt in this question?
No doubt.
Question 7. With respect to linear discriminant analysis, which of the following is or are true? When both covariance matrices are spherical and equal, the decision boundary will be perpendicular bisector of the line joining the means. When both the covariance matrices are spherical and equal, the decision boundary will be perpendicular to the line joining the means. When both the covariance matrices are spherical and equal, and the priors pi 1 equals pi 2, that means priors are also equal, then the decision boundary will be perpendicular bisector of the line joining the means. So
C. Is it option C?
yeah, it can have multiple correct answers.
B and C. Because A is saying that decision boundary will be perpendicular bisector of the line. But if it's a sphere, then the discriminating surface will be a plane, right? So it's not a line. So A is false, B and C are true.
Okay, you're saying B and C. Shravani is saying B, C. Raki is also saying B and C. Anyone else? The correct answers are B and C. So A will not be right, because it says that if the covariance matrices are spherical and equal, the decision boundary will be perpendicular bisector. It will be perpendicular, but we cannot say whether it will be bisector or not. It will be bisector only if the priors are equal, which is given in option C. Pi 1 equals pi 2. If the priors are equal, then we can say that it will be perpendicular bisector of the line joining the means. Otherwise it will be perpendicular, that is for sure. So that is what option B says, that the decision boundary will be perpendicular to the line joining the means. So that is always true if the covariance matrices are spherical and equal for both the classes. And option C is true because it says if the priors are also equal, then it will be perpendicular bisector of the line segment joining the two means. So option A is wrong. Option B and C are two correct answers. In general, which of the following classification methods is the most resistant to gross outliers? Yes.
Can you repeat the last question?
So if the in all three options this is constant, covariance matrices are spherical and equal. So if the covariance matrices are spherical and equal, the decision boundary has to be perpendicular to the line segment joining the two means, similar to what I've shown in that question, but the two centers are given 3,9 and minus 3,3. So if the covariance matrices are spherical and equal, that means the two Gaussian distributions are identical. So the decision boundary would certainly be perpendicular to the line segment joining the two means. If these are the two means, this is the line segment joining, this is the decision boundary. This is the decision boundary. It will certainly be perpendicular to the line segment joining the two centers. But whether it will be bisector or not, that depends on this prior. So if the prior values are equal, in that question also I have mentioned that if in that question the priors were equal. So if priors are equal, in that case this decision boundary line will be going through the midpoint of this line segment joining the two centers. This should be the midpoint. Only if the priors are equal, but if the priors are not equal, the decision boundary will shift towards either of the two classes based on the prior values, obviously. So is there any doubt? Arijit, yes?
One doubt. In a two-class LDA model, at a given point on the decision boundary, the class conditional probability densities corresponding to both classes will always be equal.
On the decision boundary, yes, on the decision boundary the probabilities will be equal for all the both the classes.
Okay.
Question 8. In general, which of the following classification methods is the most resistant to gross outliers? Four options are there: quadratic discriminant analysis, linear regression, logistic regression, linear discriminant analysis. Nazneen is saying C, Pradeep Kumar is saying C. Divyansh is saying A, which is quadratic discriminant analysis. Rajshekhar is saying C. Rakhi is saying C, Harapriya is saying A. The correct answer is option C, logistic regression. So the reason is that in case of it is based on the nature of the loss function that is used by the classifiers. So for the logistic for LDA, linear regression and quadratic discriminant analysis, the loss function that they use is squared loss function. So squared loss function, or L2 loss function it is called, like yi minus fxi whole square. So this is squared loss function. But logistic regression doesn't use a squared loss function. It uses maximum log likelihood. So it uses the log likelihood. So this squared loss function, because of its nature, it gives more importance to the outliers. So outliers are much more they are much more sensitive to these outlier points, because the error value would be very high for the outlier points, and it would try to correct that. So it becomes sensitive to those outlier points much more than the points which are not outliers, which are the actual points. But in case of logistic regression, as we have also discussed previously in this session, that the output value is squashed between 0 to 1, so it doesn't give much error value to the loss outliers. So all the data points would be mapped down to 0 to 1. So even for the outlier points, the error value is not very much high, so it is not that sensitive to outlier points. So that is the main reason. So basically you have to find out what cost function each of these classification methods are using. So if it uses squared error or any such polynomial error functions, loss functions, then those loss functions are much more sensitive to outliers.
One doubt: if it's a two-class LDA model, then is it necessary that the covariances of should be same? Covariance of both should be same, or can be different?
So in LDA, generally the covariance, a common covariance value is used for all the classes. So if you go through the lectures, you will find the expression. If I remember it properly, you might check there. Xi Xi mu K transpose I can't remember it properly, but the covariance matrix is common for all the classes. This is one of the major properties of LDA, that same covariance matrix is used for all the classes, so it does not differentiate between the classes for the covariance matrix. So it would be better if you go through the lecture. I don't remember the exact expression for the covariance matrix. It was a large expression. So it uses single covariance for all the classes. So covariance is basically same for all the classes it considers in that case.
Okay.
Now question 9. In a binary classification scenario where x is the independent variable and y is the dependent variable, logistic regression assumes that the conditional distribution y given x follows which distribution? So y given x, this conditional distribution that logistic regression tries to learn, follows Bernoulli distribution, binomial distribution, normal distribution, and exponential distribution.
Normal distribution.
Normal C. Okay. In chat, Pradeep is saying option A, Anand is saying A, Rakhi is saying C. Rupali is saying A. So it actually uses Bernoulli distribution. So it has y only has two values in case of logistic regression, 0 and 1. So y given x follows a Bernoulli distribution. With some probability it is 0, with 1 minus that probability it is 1. So it's simple Bernoulli distribution because there are only two outputs, 0 and 1.
Suppose there are multiple classes, then in that case?
Even in case of multiple classes, then I mean the name changes to, it's called multi-Bernoulli distribution, but it's same as Bernoulli. So with probability p1 it is class 1 with probability p2 it is class 2, like that. So it is discrete after all. There are n classes, it will still be similar to Bernoulli distribution. In that case it's called multinovely distribution or something, but in principle it remains the same.
But when during the video lecture, it was shown that it's a Gaussian distribution, so it follows.
No, y given x doesn't follow Gaussian distribution. The error follows Gaussian distribution. There was some epsilon written, I think, that follows Gaussian distribution. Y given x follows Bernoulli distribution.
So I'm sorry, I'm mixing up LDA with this thing. Okay, you're right.
Yeah, in LDA each class follows Gaussian distribution or normal distribution. Yeah, but in logistic regression y only has two values, 0 and 1. So it only has to follow Bernoulli distribution.
So why not binomial distribution?
I mean, binomial is just multiple instances of Bernoulli. So it cannot be applied to this y given x. Binomial is I mean, if you have n sequences of Bernoulli, then it becomes binomial. So you cannot apply it in case of y given x, this conditional distribution. You cannot apply on this thing.
Okay.
So we have seen methods like Ridge and Lasso to reduce variance among the coefficients. We can use these methods to do feature selection also. Which of them is more appropriate? So these are different regularizers that we have learned in last week's lessons, I think. Ridge regularizer and Lasso regularizer. So which of them is more appropriate for feature selection? Harupriya Kaur is saying B, Nehan is saying B, Ritika is saying B, Anant is saying A. Rakesh is saying B, Sai Teja is saying B. Correct answer is option B, Lasso regularizer, which is also known as L1 norm or L1 regularizer. So and Ridge is known as L2 regularizer or L2 norm. So if beta is the set of parameters, in case of Ridge, this is added to the loss function, and in case of Lasso, this is added to the loss function. And it is seen that because of this expression of Lasso, it is easier for Lasso regularizer to drive the parameter or feature coefficient values towards 0. So some of the coefficients would become 0. So if the coefficient corresponding to some attribute is 0, that attribute is removed, virtually removed from the dataset. So we are doing a feature selection in this manner. If the coefficient value is 0 for certain attribute, that attribute is not contributing anything to the classifier. So it is working like a feature selection. But in case of Ridge, even though the parameter values would be reduced, which is the actual job of regularizer, but it cannot drive the values towards 0. So most of the parameter values beta would still be non-zero. So feature selection would not happen in that case. But in case of Lasso, feature selection happens. That is, the some of the parameters would become 0. So is it okay?
What is the beta?
Beta is the set of parameters like beta 0 plus beta 1 x1 plus beta 2 x2. These are the coefficients
That's understood, but you're writing beta raised to v. It's just a tick.
Square. It is square. Yeah.
Okay. Beta squared means in red. What is beta squared? Mod of beta squared? What is
So it's basically beta 0 square plus beta 1 square plus beta 2 square. I mean, square should be outside, I think. So it's called L2 norm. So it basically beta 0 square plus beta 1 square plus beta 2 square. This is what it does. But in case of lasso, it does beta 0 plus beta 1 modulo of beta 2 plus modulo of beta 3, like this. So it takes the absolute values and add them, and ridge squares each of the coefficient values and add them. This was given in the week 2 video lectures also. So lasso is much more prone to driving the values towards 0 for some of the coefficients, beta 0, beta 1, beta 2. So if the coefficient value for a certain attribute becomes 0, that means that attribute is not doing anything. It is not contributing anything to the classifier. So feature selection is happening in that case.
okay. Regarding logistic regression and LDA, for any classification data set, do both algorithms learn the same decision boundary or different?
It can learn different decision boundaries. It can, because the logic in LDA is different from logistic regression, isn't it? So it can learn same, it might not learn same based on the data set it would learn. Now question 11. So this is the last question. So there are two classes, positive. So these are all positive points, these are all negative points. I hope the points are clearly visible, the classes positive and negative. While performing LDA on it, which line is the most appropriate for projecting the data points? So LDA is also used for unsupervised learning. That is, it can also be used to do feature selection. So it projects the data on different dimensions, and it can reduce the number of features and create new features, just like principal component analysis, PCA. So which line? There are 1, 2, 3, 4 lines of 4 different colors are given here. So you have to find out which line will be most appropriate for projecting the data points, so that it is still it can still be classified properly.
I think the orange one, just a guess.
Orange, okay. Divyans is saying C, Orijit is saying B, Archa is saying C, Anant is saying B, Rupali is saying B, Pradeep, Rakhi, Saiteja are saying B, Nehan is saying B, Harapriya is saying D. So most of you are saying B, but the correct answer is option C. So LDA tries to project the points along the direction such that they are still classifiable. So if it projects the data points on this orange line, all the positive points will be projected here and negative points will be projected here. So they are virtually not classifiable at all now. All the points will be mixed up. But if you project the points on this blue straight line, what will happen? The points are still very much classifiable. All the positive points will be in this region, all the negative points will be in this region. So it is still classifiable. So LDA, in case of unsupervised learning, tries to project the points on the directions such that the points are still classifiable. So from this diagram you can see that blue is the perfect line for that. So is there any doubt in this question?
No doubt.
Okay, so this was the last question. So if you have any other questions or doubts, you can ask me now.
May I have asked one question?
Post the last recording in discussion forum?
Last session's recording.
Yes, sir.
Yes, in the course web page there is a tab called live sessions, I think. There you have all the YouTube recordings, and also the slide links are also there, so you can find out all the links in that Excel sheet in the live sessions tab from the course web page.
There one question that from my side.
Yes.
Actually, in linear regression, I want to minimize OLS using the gradient descent. So just 1 to 2 minutes, you can just give me the process how I can proceed. Once I find the error, then I have to input into the that's loss function, right? So just tell me the process, please.
I mean, in
How
logistic regression, it's a iterative process. So in every iteration, you find out the error value, and then you have to use gradient descent to find out the updates for
can I
the
use
weights.
for the linear regression also gradient descent to minimize?
Yeah, linear regression, in logistic regression, all these methods you can use
So will
gradient
this
descent.
affect my output? Actually, accuracy के ऊपर there will be any difference on accuracy, or it will be the same?
Yeah, I mean, it should be same, but gradient descent might also get stuck in a local optima. It happens, so it's not like it might not happen. But generally, in practice, gradient descent is used for both linear regression and logistic regression.
So, sir, just please explain the process that once I find the error,
Then you have to apply gradient descent. So basically, what gradient descent would do is that for that error value, what should be the update for each of the coefficients. So the mathematical formula you can find out from any book, or also even also from the video lectures. So it finds out those updates, and you update the weight values. And
5 minutes.
regularization, sir, just one explain regularization, how we can perform the.
I mean, the regularization is basically a modification in the loss function. So loss function is the mean squared error loss function, plus that regularizer you will add to that loss function. Whether it's the ridge or lasso, you will add it with the loss function.
So this L1, L2, this only for the linear regression or logistic, or it will be
For both the regressions, this regularizers can be used. The purpose of regularizer is to reduce the value of the coefficients so that it doesn't explode. It happens in case of gradient descent that the coefficient values become so high that it does not learn well. So that's why regularizer is used to keep the values as close as possible to 0.
So this L1, L2, this only applicable for linear and logistic, or it will be applicable for other kind of the classifiers?
For different classifiers, regularizers might take different forms. Like in case of these two regression algorithms, you just add it to the loss function. In some, I mean, in case of neural networks also you do the same. In different methods, there might be different regularizers. I'm not fully aware of that.
Okay, another thing is this. Actually, LDA, some problem is there. Actually, if you ask me to perform any numerical, to do any numerical, I will be able to find the numerical problem. But still, I am facing some problem related to theory. Where I can find it properly so that I can understand.
For theory, you can go through the books that have been referred in the video lectures. That would be the best
Your
choice.
lectures are not much clear. That's very
Books
overlapping.
that are recommended in this
I
course.
think Bishop.
Yeah, Bishop book is there. Yeah, that one. There are two books, I
Pattern
think, but
recognition.
yeah, the Bishop one is good. That book.
Pattern recognition, right? Yeah, anything.
Yes,
Yes.
yes.
So
Okay,
one
thank
doubt, like suppose there are LDA for a 2-class data set. There are two data sets, and there are two classes. And data set A consists of 100 samples of class 0 and 50
This
samples
question is already given in the assignment, so it would be unfair if I
No, that's
discuss it here.
okay. Yeah, at least give some
from the
hint so
video
that we,
lectures. It's very difficult to understand
because
because
we are not able to,
finding
either
is
you
such
can implement it and you can able to find it implementation. Otherwise, just give me some hint so that I can find.
I do. I can't think of any hint in that question. If you have any, you need any clarification regarding that question, you can post it in the discussion forum. TS would be able to clarify your doubts regarding that question, but they will also not be able to answer that question for you.
So
So,
if we implement it, then only can we find the answer, or it is not possible. If we try to implement it, then the scope.
implement, no, these are logical questions. So,
That's
for
why.
one MCQ, if you start implementing the whole algorithm for two different data sets, that would be a lot of work for just one MCQ question. That is a logical question. So if you go through the video lectures and try to understand the algorithms properly, then in those questions would be answerable, I think.
Okay, this there's a question regarding a Bayesian classifier. So that follows which actually is it the logistic regression Bayesian classifier for a three-class problem. K is equal to 1, 2, 3, and they've given Sk of x for each k.
The
Then
fk of x is, I mean, yeah, it is similar to the LDA that we compute. So in any Bayesian learning, we try to compute the probabilities of a certain class for a certain training input. So it is similar to LD, but I don't know the exact question, so I won't be able to
so
properly answer.
they've given a Bayesian classifier for a three-class classification problem. K is equal to 1, 2, and 3. And for each k, they've given an Fk of x. So for k is equal to 1, Fk of x is 0.15. K is equal to 2, Fk of x is 0.2. K is equal
Yeah, I
to
mean
3.
the logic in Bayesian learning and LDA are very similar, so you can apply that kind of logic, but you have to be sure that you are properly applying those formulas.
So like for x is same here, right? So the data point that we are trying to classify is the same, and so we would naturally put it in that class k, which has the highest Fk of x, isn't it? But then again comes the question of pi 1 and pi 2. That is not very clear. Pi 1, pi 2, pi 3. If pi 1 is less than pi 2, then the prediction may not be. So what is the formula that we have to apply there in the Bayesian classifier for a three-class problem?
Yeah, I already told that Bayesian, the formulation for Bayesian classifier is similar to LDA. That the probability of g equals k for given x equals that f kx into that whole formula that is given in the video lecture. So the formulation is similar. So based on that, you have to answer.
Okay.
One more problem in Bayes classifier. We are saying one is likelihood, then marginal, and another is posterior probability, right?
Hmm.
So in likelihood, why I can't say this is also a probability? Why we are saying this likelihood and
Likelihood is also a probability, which is this fkx, right? That is the
when
likelihood.
I try to find the answer on internet, then they are saying they are the different things.
No,
So probability.
likelihood is also a probability value, but the term used for that is likelihood, and prior, posterior, different terms are used to differentiate between among them. So all three are probability values after all, but different terms have to be used to differentiate between them. Otherwise, everything is probability in that formula.
So what is the difference between this confusion matrix and post matrix?
Confusion matrix and
Post matrix. One is cost, we can that are associated with the uh, matrix.
cost matrix. Confusion matrix is each row would be there for each class, and
Yes,
each
that
column
is
would be there for each
matrix.
class. Cost matrix,
But
I'm not sure
confusion
in which context cost matrix is being used, but it might be same.
is
I'm not very sure.
related to any disease. For example, we are trying to find the most associated with that, with false positive and false negative. So which one is the more cost that will we have to pay? That's something like that. So which
There's a question like this in this assignment, or
no, that is something different that I want to discuss, not from the assignment, from other things.
no? I mean the false positive, false negatives. These terms are related to confusion matrix.
Yes.
But cost matrix, I'm not sure in which context cost matrix is being used.
Because in the real-time scenario, we have to focus either we have to reduce the false positive or false negative, right? We have to focus on one of them. Now, this there will be one cost associated with this, all the false positive and false negative.
Yeah, in
So, which
different for different problems, we use different metrics. Whether
and the next thing that the cost will tell you which you need to focus on. So, I don't understand which how the cost will be associated with this false positive and false negative. How should I calculate the cost so that I can focus on either false positive or false negative?
mm, no, I'm not very sure about that, but yeah, confusion matrix is related to false positives, false negatives, and for different problems we try to reduce different parameters. Whether in some problems we try to reduce false positives, in some problems we try to reduce false negatives.
That's okay. We got the confusion matrix, but after that, they are asking like that, which you have to focus on that false positive, false negative. Then they are saying that it will tell you the cost matrix.
There was a question last week or this week. There was a question on that thing, I think.
No, no, this is not from this assignment. That is from the different somewhere else. I have seen this question. That's why I'm asking.
Okay, you can ask in the discussion forum properly, then either me or some other T will be able to answer. But you have to properly ask that question there, what you are trying to do.
Okay, okay, thank you.
So can you go through this assignment 2 questions?
Assignment 2 questions.
Yes.
The solutions would be uploaded, I think.
Yes, solution is up to date, but some question I didn't understand.
Which question? Is there any other questions or doubts?
Five, 6, and 8.
Five is considered a modified KNN method in which KNS neighbors you do a linear regression on this. Mm, hmm. This method makes an assumption that the data is locally linear. So the first option is certainly true, because only for the k nearest neighboring points it is doing that linear regression. It is fitting linear regression line, right? So locally it is assuming that data is locally linear, so only the k nearest neighboring points are linear in nature. The first option is certainly correct. Second option is, in order to perform it, this method would need dense distributed training data. So because it is assuming that points are locally linear, for every local area you need lots of points, so densely populated points you would require in that case. Otherwise fitting this linear regression locally would not make much sense. Points should be densely populated, only in that case the linear regression straight line would fit well, otherwise it might underfit if there are not many points in the neighborhood. And third option says this method has higher bias compared to KNN, and fourth option says this method has higher variance compared to KNN. So this method is much more complex, isn't it? So if a method is much more complex, it would
What is the difference between modified KNN and KNN?
this method is the modified KNN that is described here. The method itself is described in the question, that first you find out the k nearest neighbors and then you fit a linear regression line for the k nearest neighbor points only to find out the value for the query point. That is the modified KNN.
Okay.
So normal KNN, where you go through all the points, find out the k nearest neighbors and take the average, right? In KNN, normal KNN, take the average of the k nearest neighbors. Here they are not taking the average of the k nearest neighbors, they are fitting a linear regression model for the k nearest neighbors. So the model becomes much more complex than the normal KNN. So if the model is much more complex, it is prone to overfitting. So a overfitted model would have high variance. So that's why the last option is also correct, that it would have higher variance. Question 5, and what are the other questions?
Two, 6 and 8.
2 is very easy, that if the feature x1 doesn't have any the correlation is very low between x1 and y, almost minus 0.005, that means x1 is not correlated with y. If the feature is not correlated with y, then there is it will not be able to find out any meaningful coefficient if we regress y on x1. If there is no correlation, it is almost meaningless to predict y on using that feature. So that's why regressing y on x1 mostly does not explain away y.
So as it is minus 0.0.
Yeah, I mean it's almost 0, isn't it? Yeah, the correlation value ranges from -1 to +1. Minus 0.005 means it is almost 0. That means there is no correlation between the feature x1 and output y. So that means x1 is not related to y at all. So if it is not related, it doesn't have any impact on output y. And what were the other questions?
Six and 8.
6. Reaches sparsity constant, it will drive values to 0. Yeah, this question I already discussed. Ridge regularizer and lasso regularizer. Lasso is much more prone to driving the values to 0, and it also reduces the number of features or variables, but Ridge cannot do that. And what were the other question?
Eight.
8. So 8 is the difference between the stepwise selection and stage wise selection. So in the first statement says that in each step the variable is chosen which has the highest correlation, the residual regress. Yes, the stepwise is not this. In stepwise is a greedy method. So in every iteration we add one feature to the set of features that we already have if it improves the performance of the model. So it's a iterative method, and in every iteration we pick the we take one feature and we try to find out whether it improves the performance of the model, and if it does not improve, we remove that. And stage wise, what we do is that in every iteration or every stage we find out the feature which has highest correlation with the residual, and then the residual is regressed on that variable, and based on that we get a predictor. So in this method we also get a predictor in case of stage wise. So that's why both these statements are wrong. So basically the statement 1 is true for stage wise, not step wise, and statement 2 is true for step wise, not stage wise. So the statements have been reversed, so that's why both the statements are wrong.
Interchange, it is interchange.
Okay. If there are no other questions or queries, then you can end this session here. And thank you everyone for joining.
Thank you, sir.
Thank you.